Hi, guys. Nice to be here. I have really heavy task, be the last one. But I have something really great for you. And let me start with some words first in personal matter. Let's say I'm really glad to be here. Why it feels like come to home. Let's say working in the hyperscaler company, you are jumping around the world, or running, and coming to Zagreb, it feels good. Thank you for that, Jelka and guys. Now, DAVOR ANDRIC, my name. I am Principal Technology Leader, Global at AWS. What it means, what are my objectives and goals? First, to evolve AWS core services to be better fit for AV. And what it means, 4 years ago, I guess, in the Algebra, it was one of the first A to Future. I talk about hundreds of petabytes of data for AV and how that works. But now it is even looking for the level 4 and 5. The challenges that you need to have, it is about intelligence. We heard a lot about the data. Data are great and you need to have it. But it is more about the sentence in the data, to pick the right data that you have value in and to grow on it. AV, here, today I will speak about how to scale intelligence in fully automated driving. And let's jump into first, a little bit overview about the AV goals, what it means. Then we will look into it, how to build it on the usual level that are cars that you will observe on the street. Let's say S-Class, currently, as we learned, hitting the level 3, which is great. But then it is there to help us. And I will go into that, what it means to help us. On the end is to get some time back. Driving in the car, hey, and having 2 hours slowing down and to have your mind centered in something else is a great thing. Okay, then we will look into how to scale the intelligence and what are really challenges for level 4 and 5. And little appetizer, it is not data. It is compute that is killing us, killing the intelligence. Or let's say, not killing the intelligence, but there is tight coupling between scaled intelligence and resources. And AV, to address AV, you have to solve the problem of interaction on the human being in the complex environment. That is heavy. Okay. The last step I will address to what it will take to develop better driver, to give you a little bit outlook where autonomous driving may land. Now, the goals of autonomous driving are first, of course, to move and change mobility, to move people, but not just the people as humans, but also goods. And moving goods, it indicated something that is closer to be applied. Having tracks driving in the reality from hub to hub on highway, that is something that may come in the next quarters. But having fully autonomous driver taking over and being hands off, eyes off, and brain off, that will take time. And okay, one important part in the entire AV space is safety. Why? Having companies taking the risk of human life just to have self-driver in the name of the future in the car, I think is not great. It's just my opinion, personal. It's not the greatest way to grow our market. And as we see, but the trends on the what OEMs are doing, and OEMs, it means companies like BMW, Daimler, Volvo, being really keen on safety because it may, if you do it wrong, cost the lives. And that is a huge thing. Okay, how to build autonomous driver? In the past, autonomous driving systems, and it is above level 2. Let's say it's just about the driving function, like ACC control is driving function that follow the lines, brake and accelerate. Having elasticity on everything is nice, is level 2, and how it was developed is, let's say, some kind of revolution looking in the past. In the past, let's say you had simple assistants like Tempomat and similar things. But to grow from level 1 to level 2 is revolution. It's revolution for the industry. And what it means by revolution, the humans have done decision-making by couple data points. They had 10, 20 data points, and human have done analytics by his own brain and just comparing some visual and data points. Looking in the future, or let's say now is not the future now, already there, we are already there in the level 2 plus. Level 3, Daimler have started SOP for the S-Class, level 3. And that is a huge, huge step for the industry. What it means is paradigm change where liability change from us as driver, human being, to the auto company. That means if in case of issues, the auto company is liable, not the human driver. That is huge, 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 huge. And not all companies currently in the world are ready to do so. Daimler have done the step because of the excellence and knowledge that they, or let's say, what they have, but not all the companies. Huge thing here, looking at the revolution, what it means. The machine learning models are helping to make the decisions. The human is in the loop just to verify something. And I am in the AWS team named HIL, Human in the Loop, working in the engineering team. It is the team where reinvent happen. And we are building the services, but also operating them. That means building something without being reliable and sure what you are producing, it puts you on the risk. That is why it's rare that Amazon engineering team coming to the stage and putting, let's say, the services that they have still built it directly from the user. That's happening in the reinvent with pretty clear defined user group and then looking from there. And by the way, I am not here to sell something, to tell the story about autonomous driving. Here, huge step then in the revolution between level 1 and level 2 and 3. This revolution. How it looks like, let's see, looking at the ADAS and level 2, how the driving behavior and motion planning stack usually looks like. It is given here. The left side is pretty mature. That is already there for years. Being in the auto industry, AUTOSAR classic is given there and predefined. But on the right side is something where the revolution is happening already now. And what we see is still, it starts with basic programming model, then having deterministic rules as part of it for decision making, and deep neural networks. And in each of the building blocks and components here, where you see D and N, is already happening. The deep neural networks are trained day to day with, let's say, smart data sets. Out of 200 petabytes, we get the sense out, and just the reliable test cases, they are humanly verified, are fed into neural networks models and integrated into the entire system. To do what? First, to create the driving context, to understand, hey, in which situation the car are in. Okay? Then to fuse the data, and fusion is happening on real time. Fusion means, and I will point it later on, the cars are trying to mimic human perception, okay? And to do so, you have to do a lot of work that human brain intend to do, is to recognize things, to classify it, and be fast in the setting the context. And that is something that autonomous driving system have to do on real time with requirements between 20 milliseconds is fine to make decision, okay? That's huge. To do so, of course, you are on the edge. In the cloud, you have different type of machines, of EC2 instances, virtual machines, whatever. And you have power in it. In the car itself is HPC controller. Of course, your power here, we are looking to evolve, but still is limited. And you have to be pretty aware about those changes between the environmental parity between the cloud, and the cloud where you use it as a backend, huge backend platform, and on the edge side, the car being capable to make decisions with less data. ADAS level 2 is good for, let's say, some pretty predefined. We name it smart, in math, it's known as small world problems. That means your problem space is predefined. It's not, let's say, covering everything. Here, it is highway pilot, traffic jam. Automated parking may be really complex, believe or not, but it is. And that's fine. Level 2 plus, cool. What it means, which challenges have to be solved even to have level 2 plus car. First, it is about perception, as I said, in the human brain. And what we're trying here to do is to train machine learning models first to mimic to perception. And we have here urban scene perception, which on the left side with A is building blocks or labeling, and that is how to start. Start with the labeling. Start with giving the sense, them labels with a, let's say, some kind of segmentation. And then segmentation for the objects. And where it really kicks in is connection between the 2D world and 3D world, where the LiDARs come in, and when the car have exact position, or let's say they are able really to know exact position in each object in the entire world around. And it is not local, it is really global. It is used by distant GPS IMU, fusing them together, and you get the right side here, building the 3D view in the vector space. And what is done there, on the left side, we have pixels. We have sentences for 2 pixels in 2D space. We are growing in the space itself into 3D, and then we have to switch and fuse them together in something that is vector. It moves. And then to know each object to which time will move in which direction is heavy in small car, but it is happening. The challenges in level 2, it is great where we are now, and a lot of the OEMs are already in level 2. Few, just one is level 3. Level 5, different story. There are a couple of companies, candidates for that, but we may not be able to say, hey, they are there. Why? They scale differently. The level 2 and 3, usually ADAS, scales per driving function. We add more and more driving functions. The car is, let's say, helping you, and that is how the intelligence scale, which is good. Level 5, try to address huge scenario level of problems that humans are handling easily, but they are growing over locations. That means you will see Waymo, Cruise. They start in Phoenix and covering one part, then it grows. And I was there 2 months back and visiting some colleagues. Even the area in Phoenix, it grows. And covering the, let's say, from small part to bigger part and scaling on the geography. The same thing in San Francisco. That means the problems that you have to address with those 2 types are different, and they will converge over time, of course. But to do so, ADAS, first, is not intelligent. Machine learning models usually need thousands of data to understand there is the tree. And not really excellent in the overall entire results, because they are solving just small problem. And in those problems, they are good, but that is why I ask a question. If you change a situation, looking from left to right, your model may run crazy. And to limit the impact of the change from the entire world to decision-making, guys that are doing neural networks, deep neural networks, know what is really challenge. It is. Hundreds of petabytes of data, of course, are still there. and we have to manage it. The way how that works is usually the data that you not touch, you should shoot down. What it means, push it into archive. And just using the hot data that you need, let's say for your retraining, test scenarios, whatever, that help you to have price-performance balance that you need in your system. And that is the case also for the startups. Data that you need, keep it hot, rest, and there are data lifecycle policies, put them in place, cool it down. And more important thing, and that is what is the entire story here about, is how to train and how to scale the intelligence. You need really huge dependency between the resources. And data are first point, but compute is even kicking a lot more. And I will show it now in which dimensions. And it is not just about which cloud, guys. It is about you need to compute like the planet to address something that we are talking and thinking it's part of now. It is not. We have to change something. And that is how to build a full autonomous driver. Usually, let's say a level 2 approach fail to describe the real world of the problems. As I said, teeny focusing on the small worlds. And it didn't ensure the autonomy, let's say fully autonomous driving. But we are going there. It is step by step, and having safety in mind, we are coming there. We are moving, but it will take time. But to address really level 5 and go broader in the scenarios, we need to change how to train the models, and we need to change the paradigms. We need to think into direction of specialized AI. And I am not addressing GAI with purpose, because it is here not the case. It is about the application of specialized agents replacing the driving function with scenarios and learning them. How that may happen? First, level 5, it should be about customer tangible and usable and safe features. What it means, tangible. Tangible is, for me, the sentence that I said in the beginning, giving time back, but feeling safe and respecting the safety standards that we have with purpose. I know, let's say, and trust me, as you have to go fast, a small startup, you are doing with purpose, getting into some technology, but also liability, how to say it? You are gaining into that and taking it as given. But later, as your maturity is growing, to compensate to doubt that you had done in the last 3 years may break your entire business model. That is why all the time it is break-even between go fast, but still having the purpose technology, but also the business model to grow there. Adopting the broader customer usage need, of course, robot taxis are great, but still currently we are missing thousands of truck drivers. To save this problem, we should help, let's say, and apply AI to solve some real problems that we have today. And of course, build safety to use accept AV system. Resiliency is important. And we have to solve most hard problem, how to scale the intelligence. I will try to address it now. I guess I have still a little bit of time. I see here 4 minutes, but I hope, guys, it's fine to have 5 to 10 minutes longer. Okay, good. Level 5, what we have today. What we have today, and it is proven to the different studies, how the intelligence grows here under A. I put it on grow the accuracy as function of the model size. Okay? To be better, usually your model have to grow. Okay? Usually. There are some applications to, let's say, work on that, but still it is most important factor in dependency. Next one. What we have here is OpenAI bring the proof that still AI models are learning over time, but there is huge dependency between the needed computation resources on the left and train the model and accuracy then. What we have in the middle, it seems, hey, it grow nice over years, but it's not true. And that is how you present your data, right? Here, the graph is logarithmic. That means having logarithmic scale, but growing like crazy, exponentially. That means that hit the roof in, let's say, milliseconds. And the most important message here is to address level 5. We know now, and it's proven, we have dependency between the resources you use to train and intelligence, how to scale it. And currently, the line with A, it shows where we are here, and what do we will need to address level 5 to put into effort, to grow. That is why Waymo and entire level 5 company area are spending more on the compute and everything else in the company. To grow intelligence, you have tight dependency between storage, smart data, but even more compute and GPU dependencies. Now, to scale the intelligence, we have to change the paradigm how we learn for level 5. And how to learn, that means to flatten the curve. To flatten the curve means you have to, then, let's say, looking back from the customer, what is customer using, and AWS is really crazy in the customer obsession. And we are working with entire set of the AV and ADAS companies, 50 to 70, and working day for day with them, helping them to evolve their models and building the backend for them and so on. We see the need to flatten the curve by changing the paradigm how to learn in the model. And how that may work, first, big picture. okay? In the middle, and at Amazon, we are crazy on the fleet wheels. That means each mechanics that we have, process in place, have feedback loop, and we are learning and evolving each time. And that is here what we see in the central model. Of course, scale driving agents to move from A to B, humans and goods, which is great. We need some technology, great. We need to build driving system, great. We know that, it's happening. We know safety is a huge thing. We have to validate and verify respecting safety ISO standards they are in place. Check. And as we have built an autonomous driving system, we are happy. We have to deploy it in the car. Check. And now it comes the tricky part. And tricky part is how to scale. You have to scale scenario-based, and scenario is take over. Okay? Simple thing. And a lot of the scenarios are there. Thousands. 100,000. But the scenario has to be trained for location. If you drive in India, you are going crazy. And to learn the model to drive India, it will take time. But to learn the model in Germany to drive, it may work. And that is here the driving task as, let's say, important parameter for scale the intelligence there. And the math is the king. That means you have to respect theories they are in place for 20 years. And it is no free lunch. The magic is not happening. If you train your models, and let's assume you are good with 20 scenarios, which is hard, but adding more and more scenarios, your model is, let's say, the accuracy of the model and flexibility, it's going to have impact. Or even more, if you learn with more data, the model is starting to forget. And that is proven in the theory. There is no wizard. And you have to search for the break even between them. And power law, sorry, I forget the most important thing. Here, the entire story is about the power law. And power law is proven here by Google, OpenAI, and that is how we see the world. And power law is the driver for the balance in the AI. And of course, regulatory policies and law enforcement. If you have level 5 cars, okay, and you're driving around and the police officer is going to stop the car, who is going to interact? There is no one to speak with. And that is a huge thing. Okay, how it may work? We need, let's say, paradigm change. Here, one example, based how the based on theory, how life organized, including mine, is built in 3 different levels. First is the level in T3 is the way to learn to drive knowledge, how to drive will learn. And we name to this level evolution. And as we have learned traffic rules, regulations, and terms, we are using this knowledge as abstraction and being applied in the next level. In the T2 level is more operational level. To learn, let's say, having the knowledge base, then learn how to apply different situations, and having, let's say, smart agent for the broader situations. And then, after that, if the situation change, you're driving through the tunnel, and the car have to understand, hey, I am in the tunnel, and not to act like crazy. That is where the T1 label kicks in, using just a couple samples to adapt to the context and make right decision. And that is crucial here. Paradigm change and using different approach to address a broader scenario strategy. What it needs fail fast, evolve, and that means in the R&D development cycle to short it from 6 months, 3 months to days. And that means the entire hardware that you had in the, let's say, hardware in the loop have to change to software-defined vehicle, data models, and have entire training and learning in cloud. And in cloud, AWS, here the view how we are doing it. And as I said, infinity loop and workflow is something that is crucial. And we start always with the customer, understanding what the customer need and helping them. And that is the left side. First with the car, collecting the data, then storing the data here, data lake and serverless compute, and as broad base is the key. But still, we are keen also to provide the best price performance for the customer, where we say extract the metadata and useful data out of the hundreds of petabytes of data, providing to the customer being capable to learn out of that, search for that, and use those data, and still managing it down to kick down the costs. And of course, on the right side, you have a lot of machine learning operations, but also perceptions and traceability and acting. And then, and then the area where AV really is at home, bringing it in the car, into VECU, having software in the loop, validation and verification, and then looking in the car how to deploy it and keep it in the service for the reasonable price. Okay, that is how we see it. And one important message on the end: if as all complex areas in the field, AV is one of the most complex ones. And by making decision to go fast, you may go alone. It's your startup. Even Waymo is great, but to go on long term, you have to go jointly and to join the forces. That is where we see a lot of consolidation on the market. How we are supporting it is given here. We are the founding member of the SOFI, where AWS is helping the customers, bringing the base already to start to validate and verify autonomous driving. And the association is growing day for day as we see the major companies are joining in to grow together. That's all. Now questions.